So now I'm going to talk about exponential functions. And exponential function with the base a is defined as f of x equals a to the x. So here a is representing the base of functions, which is just a number that is greater than 0 but not equal to 1. So if the bottom is a number and top is a variable, so this type of functions are called exponential functions. So a can never equal to 1 because 1 raised to any power is 1, which will just be a constant function, not exponential. Okay, so exponential functions will always have this form, which you have a number on the bottom, which we call it the base, and then the power is a variable. Okay, in this case, we're just using x as a variable. Okay, so that's called exponential functions. Okay, now here are some examples. For instance, the function 2 to the x is an exponential because the base is a number and the power is a variable. So here the base is 2. And for the function g, 3 to the x is an exponential function with the base 3. And the function h is an exponential function with the base 10. Okay. In a little bit, we're going to talk about the graph of this type of functions as well. So that's just a basic definition. So here is the function. Exponential function 3 to the x, and when we evaluate an exponential function at a given value, we're just going to plug that value for x. So for instance, in this case, we'll just plug it 5 into the x. So this will be 5 to the power 3. And if you have to use your calculator, you can exactly enter it as it is. So use 5 as a power of 3. And then over here, you will do now your input, which is this is x, so that will be negative 2 over 3. Input is negative 2 over 3, so this will be 3 to negative 2 over 3 power. And this is something that you should use a calculator for. And then same thing here, this will be x is pi here, so this will be 3 to the power pi, which also you need a calculator. So this is also 3 to square root of 2. So here how you use a calculator to compute this, so you can exactly enter it like this, 3 to the 5th power, which the output is 243. So the answer here is 243. And then for the other example, and that's exactly how you put it in your calculator, which you can just use the same notation here, and that's what you get approximately. This is the answer. 3 to the pi is close to that number, and that's exactly how you put it in the calculator, and that's exactly how you put it in the calculator for that example, and same thing for the last one. Okay, now for graph of those type of functions, those are parent functions simply, like this guy and this guy are parent functions. So I'm just going to show you the graph of parent functions now. Okay, so let's say we take this first one, it's 3 to the x, and the second one is the base is 1/3. So one of them, the base is bigger than 1 because 3 is bigger than 1, and the other one, the base is between 0 and 1. So let's see what is the main difference between these two. So for exponential function, domain is always all real numbers. You can choose whatever you want for the x value. So here I choose from -3 to 3, all integers. But you can choose a different set, so that doesn't really matter. Okay, so then you plug in, right? So 3 to -3. So you're plugging -3 for x, and 3 to -3 in case if you just have to use, you do this by hand. 3 to -3 is really just 1 over 3 to 3, and 1 over 3 to 3 is 1 over 27 because 3 to 3 is 27. That's how we get that number. And then the second one, you plug in -2, so it will be 3 to -2, which is 1 over 3 squared, and that's 1 over 9. And we'll put that there. So if you keep on doing this, and 0 power of any number is 1, that's this, and then 3 to 1 is 3, 3 squared is 9, and so on. So you find all the y values for the first exponential function, and you plot them. And once you plot it, you'll get this red graph. You'll get this red graph, which we call it increasing function. It's always increasing, and in applications we call this growth function. So this one is a growth function. which means the increasing function. And then for the other one, because 1/3 is a reciprocal of 3, so then you'll just do the reciprocal of each of this. So if you just keep on taking the reciprocal of each of this number, you'll get this one for the y values, and that will be this blue graph, which is completely opposite of this growth, right? So this will be decreasing, and for decreasing, we use decay. So this will be decay function. So simply, I'll write down the more general definition for this. But simply, if your graph is like that, increasing, it's an increasing function, then it's called a growth function. And if the base is between 0 and 1, then it's called a decay function, which I write it here. So the base is bigger than 1, it's growth. If the base is between 0 and 1, it's a decay function. And then all other transformation rules will also apply here, which we discussed in the previous videos. So you can do the same type of techniques and apply here. All right. So now I wanna look at, for comparison, I want to show you this. So for instance, if you start with 2 to the x and then increase the base to 3, and you see it's going to be a vertical expansion. So when the base is increasing, when the base is getting bigger, then the graph is expanding more. If the base is getting smaller, then it's going to be compressed, right? So, and you can easily look at the different type of graph and be able to tell the difference. Okay. Now, and that's all listed over here in this definition. So I want to show you this. Okay. So the domain of this is a parent function. So 2 to the x, 3 to the x, without translation, of course. If there is no translation, then this is called a parent function. And for the parent function, the domain is always all real. Domain is all real. The range is always between 0 to infinity. So you see, when a is bigger than 1, which is when base is bigger than 1, you get an increasing function. So like I said, we call this the growth function. And then when the base is between 0 and 1, it's decreasing function, and we call this decay function. And both of them has the same domain and the range, basically. Okay. All right. And by the way, the function, for instance, if I take 2 to the x, right? 2 to the x will approach to 0 as x approaches to infinity, or negative. When x approaches to negative infinity. And 2 to the x will go to infinity when x is going to positive infinity. If you look at this graph, and that's exactly what this is saying. So if x goes this way, then the y is going this way. But if x is going to negative infinity, and you see the y values are approaching to 0. So y values are exactly approaching to 0 here. Okay, so here is just a different example. For instance, this could be like y equal to, when x is 2, y is 25. So this function is like 5 to the x. And this one is y equal to, when x is 3 and y is 1/3, 1/8. So that's 2 to the negative x, basically, right? Okay. So one important application of exponential function is compound interest. And the compound interest is basically an exponential function for calculating the compound interest. So if you have an initial amount, which we call principal, and the letter P is for principal, and you invest this at a certain rate during certain time, then after one time period, like after 1 year or after 4 months and so on, then the interest you will get is the rate multiplied by the principal. And the total amount of money that you will get at the end of that period is basically the principal added to the interest. So principal added to the interest is basically P times 1 plus I. And then if you just keep on doing this, if you keep on doing this, for instance, now you have this one after a certain period of time, and if you keep on applying the same interest rate to this amount, then you will keep getting the different power of 1 plus I. So this one is 1 plus I to the 1, this one is 1 plus I to the second power. If you keep on doing this, you'll get P times 1 plus I to the third, and so on. And if after K periods, then it will be 1 plus I to the K power multiplied by the principal. So this is called exponential function. Of course, it's an exponential function form, and we will call that a compound interest after K periods of time, right? So if the annual interest is R, and if the interest is compounded, let's say n times per year, then each time period, the interest rate will be multiplied by n, because you're applying n times during 1 year, and the number of periods will be n times t, if you're using t years. So basically, overall, to make this short, we will be using this function here for computing the compound interest. So P is the principal here, R is the rate, N is the number of times, and this is the number of times multiplied by the time period. So we will be, when we use this, then we will be able to compute compound interest for any given principal. Okay, so let's look at an example. Okay, so let's say we're investing $1,000 at interest rate 12% per year, and find the amounts in the account after 3 years if interest is compounded on different periods of time. So like annually, semi-annually, quarterly, monthly, daily, and so on. And then we will be able to compare which one will give us more total, right? Like accumulated more. Okay, so annual means n equals 1. So you're just doing 1 times a year. And then semi-annual means you're doing twice. And quarterly means you're doing 4 times. Monthly, 12 times. Daily is 365 times. And the P is 1,000 here because initially we have when you put in $1,000. And R is 12%. So that would be 12 over 100, which is 0.12. And then we're doing this for 3 years, so T equals 3. And then all I need to do is take these numbers and plug it into this formula here, right? So here's the first case. So when n equals 1, then I plug it in, I plug everything in here, and this is the amount I get. When n equals 2, I plug everything in and use my calculator, of course, and then I get this. So if I just check all of them, then I'm getting this. And you see this is more, right? So that means daily is the best, right? Daily is the best if you're doing compound interest. So I hope this makes sense. So you can try, more problems to kind of practice and try to understand the topic well by maybe listening the video more and then try more problems.